Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this max length chain problem of GFG. So let's move on to the problem, guys. So here, this is very interesting problem. First of all, I am just telling you the problem statement. Like we are given n pairs of number, but here we are given a pair in struct form. Like this is a structure. Like this is the pair of. Okay, we are given a array of this struct type. Okay, so each like this is the array given to us, array of type struct, and name of the structure is val. So struct val is the data type, we can say, and p is the name of the array that we declare. So p contain pairs, n pairs, so n is given. Now we have to find out the maximum length, or we can say the maximum number of pairs we can include in a chain so that his condition can be satisfied. Like if a pair cd is followed by another pair ab, then it should be b greater than c. Like what is, like here it is 1 comma 2 is other pair. Suppose 1 comma 3 is other pair, 2 comma 4 is other, and suppose 3 comma 4 is 1 and 4 comma 5 is 1. So if this is the pair, then the next pair, it should, the chain should follow, should have first value greater than 3. Like 2 cannot possible because 2 come before, so uh, chain cannot be possible. So 3, no, 3 or 3 can be possible. No, 3 and 3 cannot be possible because it is given that b should be greater than c. So this should also not possible, but this is possible. This 4 comma 5 is possible. So next is 4 comma 5. So the length 2. But now if 2 comma 4, then we cannot take this. We cannot take this. Okay guys, so we have to find out the maximum length of a chain that we can make. So how we will do it? So just let's suppose for this example, just copy paste this example. This is a very interesting problem, but here time complexity is the biggest factor. Okay guys, so this is the array given to me. Okay, the brightness. Okay, so first of all, what I will do, I will sort the array. I will tell you why. Because if I am sorting, then I can use, like, for this pair a comma b, I know the only valid next element should be here, because the array is sorted, should be come here, should become next after it. Then I can take c comma d. Suppose there are some pair that I cannot take because of some limitations, or they are not fulfilling the condition b greater than c. Now after we again left some, then taken e comma f, e comma f. Then if this is not sorted, then suppose c comma d is here. So we have to traverse here from here to here to here. Then like after c comma d we have to go to e comma f. So this is very confusing, like where we have to go. So we will just sorting it so that we know for a particular pair a comma b, our answer, our next possible pair should be on the right side of my a comma b element. Okay, so index should be increase of the next chain element. So this is what I want to say. Now I just erase it and tell you the initial logic. The code is very simple. The logic is hard, code is simple. So I will sort it. Like how I will sort it. First is 5, 24, 39, 60. I am sorting it. So after 5 comma 24, next one is 15 comma 28. 15 comma 28. Then after 15, 27 comma 40. 27 comma 40, then 39, 60, 39, 60, then it is 50 comma 90. Our sorting is complete. This is, these one are the starting, these one are the ending point. So now suppose we are starting from here, suppose for a minute we are starting from here. Now, so what we will do, we will starting from last. I am telling you the code approach with this, the how I am doing the code, because memorization will not going to work here, because the n should be n can be 10 raised to the power 5. So memoization will not work. You can see I also wrote a memoization code, but this will give me segmentation fault. Okay, and I am just seeing the size of my vector and all thing, but then I just write application code and it's submitted. So now we are starting from last. So each element for each element we have two choices. For each element we have two choices. Just a minute. Yeah, okay. So for each element guys, I have two choices. Either I can take it or not. So suppose for last element, if I take it, if I take it, if I not take it, suppose. Now for last element, what happens? So now for the last element, suppose if I am taking it, I take it, then I cannot take other element. I cannot take other element because after or what I can say. So what I can say, I will take the next element whose first element should be greater than 90. So we don't have any element. So our maximum number of chain length we can go if we take it 50,90 is 1. And if we don't take it, we will 0. Means we have one element and we are not taking it. Now, okay guys, this is complete. This one is complete now. After completing seeing this example, you will clearly got what I want to say. Now for this also I have to take or not take. If I am not taking it as well, if I am not taking it as well, then what you can see. So here, and here you can see dpi means dp value. Dpi value is a maximum. Dp value is always store maximum. Why maximum? Because for I for chain length starting from this index till last, it will store the maximum if I am taking it and maximum of if I am taking it or not taking it. So maximum is 1 means we take it and the maximum we got is 1. So dp 0 1 2 3 4, dp4 is equal to 1 means we got one chain length either by taking it or not taking it. Dp does not mean we got this by taking or not taking. Dpi means we got this much length if we consider this element in my chain or not. I don't care about it. Now for index 3, now for index 3 what is the case? If I am not taken it, if I am not taken it, then suppose I have this much length and I am saying you I am and I am saying to you what happens again and again. Okay, and I am saying to you I am not going to take this element. So remaining length is this, means from 4 to index n till n. This is other issue that 4 is our first element. So what I can say, if I am not taken this element, the maximum chain length I can go is from 4 index to last. Now what is dpi? dp4 is 1. So if I not taken it, the maximum length I can go to is 1. Means after 4, after 3 I have 4. So from starting of 4 index, if I exclude this, I will go chain of length 1. Okay guys. Now mm, this is and not taken. Now what if my if I am taken it, what if I am taken it? Okay, if I am taken it, if I am taken it, then it is 1 means I consider this element. Then what is the next element that I can take? Next element should have first value greater than 60, but we can see we don't have any value in my left array or in my left struct value array which have value greater than 60. So what I can say, one element I can take it, and else we will take a 5 here, 5 index here, we don't have any value, we don't have any take in tag, and dp 5 is equal to 0 means we don't have any value, so dp5 is equal to 0. Now for 60 we can say 5 is or we can say I am putting infinity here. I am putting infinity here. So 60 will say 5 is the index which will fulfill my choice. So it is 0 means we don't have this element. We are just imagine that we have some element at index n, but indexing is still n plus n minus 1. So what we are see, 1 take this then plus 0 because we have just imaginary element, we don't have any real element. Okay, we can say like this. This is will I will tell you why I am taken this. Why I am taken this till the last you will go to know this complete. So it is 1 comma 1 again, or I can say this is 1 comma 1 again. So the final answer is maximum of 1 plus 0, 1 plus 0, that is 1, and 1, 1 comma 1 is 1. So you can see if I am taken it, then this is the only element, this is, then this is the only element I can take, and if I exclude this, this is the only element I can take. So either, in either way I will go to 1. So dp of 3 is 1. Now I am at index 2. Now at index 2, so first of all, not take. If I'm not taken it, then I am left with this. So the maximum chain length I can go is dp of this dp3, that is 1. Okay, now I am saying I am going to take it. This is a very interesting example. You will see a base case here. If I am taken it, okay, I am taken it. So 1 for this particular element means I take one element. Now, what is the next element that I can take? Either I can take 3. No, I cannot. I can take 4. Yes, yes, I can. Why? Because 50 is greater than 40. So if this is the pair, 20 comma 40 is one pair, then the next pair can be 50 comma 90. The next pair can be 50 comma 90. So 50 comma 90 can follow 27 comma 40. 50 comma 90 can follow 27 comma 90. This is one case. So what I can say, I can take chain from this index. This is the first index which I can take. So I can say the chain of length then that I can have from starting of this element will be add to my take. Means I am taken this, then I am excluding some part. I mean, this is a chain that I cannot take because starting element is less than 40. Okay, but I can take this. So what I will say, if I am starting my chain from this element, I am taken this, then the next element is this I can take, and from this the chain length I can have is 1. So 1 plus 1, it will become 2. So maximum of 2 comma 1 is 2. This is an interesting thing. 2 plus 1 is 2. Now you will just see this one example, you will got what I want to say. Actually this infinity imaginary element for making, if my like for 90 I don't have any element, then I can take, if I'm taken this, then I will add 0. I will add 0 here, I will add 1. Why? Because I have some element, so I will take this, that dp value. DP value should be at least 1. Why 1? Why 1? Because I am always free to choose a single element. Okay, so DP value will minimum 1 always, minimum 1 always. If I am giving you pair like 1 comma 1, 1 comma 1, all values same, then you cannot take two pairs. Okay, then dp value for all particular pair will be 1. Why 1? Because if I am taken it, then I don't then I have the last element, I have infinity. So this next element I can take is this, the dp of this is this. So I always have one element at least. Okay, that is what I want to say you. I always have a single element means 1. So dp of the last is 0 means I cannot have I don't have any value. So it is 0. This is just an imaginary value to save you from out of the bound. Now we have done with it. Now we are at this index. Now for not taking it, if I am don't taken it, then chain length remains with us is this. So if I am excluding this, then the length of chain I can go is from index 2. Now what is index 2? What is the length of chain that I got if I am starting from index 2? It is 2. So I just change a color, changing it to this, it will become 2. Same color, not good. Okay, 2. It is 2 for this element if I'm not taken it. Now if I'm taken it, then 1 is this value. Now what is the next value that I can take? I can take this. No, 27 is less than 28. I can take 39. Yes, I can take 39. I can take. So I can say after this, the next value I can say this. So after this, after taken this, the next chain length will be starting from here. So what I will say, the maximum chain length starting from 39,60 will be added to my taken value. Now what is this? This is 1. So 1 plus 1 is equal to 2. So maximum of 2,2 is 2. So from starting this, I can say I have two chain length value. If I am excluding this, then I can take this. and this. If I am including this, then I can take this and this. So these two value will always gives me answer is equal to 2. So we have completing this index as well. Now we are at the last and the most important index. Okay, some other color that will give me freedom. Yes, blue it is. Okay, now if I am not taken it, chain length is this. Not taken it, chain length will be 2. That is dp of next element. Now what if I am taken it, what if I am taken it, it is 1 plus the next element, the index, the, or I can say that if I am taken it, then what is 1 plus the dp value of next index that I can take. What does it mean? What is the next value, next index that I can take after 0th? Now what is the first value that is greater than 24? Is it 15? No. Is it 27? Yes. So after 24 I can take on this. So what I am saying, 1 plus dp value of this index, this is 2, dp value of this index, that is 2. 1 plus 2. This is simple as that, as simple as that. This is 3. Maximum of 3 comma 2 is 3. So what is my maximum chain length? This index, this index, this index. These three index I can take to make my chain length maximum. So my answer will be dp is equal to 3. Now guys, now this time complexity is n square. Why? For each index I am taken in its next length, at which element I can take it. But you can see this is just like searching. For a particular index, I am searching in a particular range, that what is the next index that is greater than this 24. So I can use binary search here. Binary search. So my time complexity reduced from n square to n for each element, and log n for searching next element. For searching next element. And for each element into, for each element I am searching the next element in log n time. So time complexity reduced to, just a minute, this may feel like jargon to you. Okay, so the time complexity will be n for each element I am searching the next, that is n log n. So time complexity will be n log n. This is a minimum. As well, for each element n, you are running a loop of n times, so it will gives you n square time complexity. That is not acceptable. Why? Because n is up to 10 raised to the power 5, so n square will be 10 raised to the power 10. That is not acceptable. But for 10 raised to the power 5, n log n is very simple time complexity. It is easily acceptable. Okay guys, so this is just I am converting it to code. How? Just look. Okay, I cannot make it. So this is the array given to us. I will show you memorization code as well, but first of all I am sorting it. How I am sorting it? Based on starting time, based on like p comma p plus 1. Now this is a comparator method. You can see some post on lead code or GFG how I am sorting the vector with my own compare function. So I am writing a compare function like for two index. If the first element, like suppose if I have a array that will say me 15 comma 20 and 15 comma 10 and 17 comma 9. So when these two will be compared, the first index should become of 15 comma, it cannot be, suppose it is 16, because ending time should be greater than starting time. So it is 16 comma 16, then 15 comma 20, because I want to take as minimum range as possible. Because after this I can take 17 comma 19, suppose it is 19, 17 comma 19, but after 15 comma 20 I cannot take this as well, because I am searching for each element. You can take anything, but I just write it. Okay, so if my second element of I dot second is smaller, so it will place first. As well, if both are different, starting time are different, then the minimum starting time is should be placed first. Okay, now I am taken a dp of n. So and size is memory requires on, it is saying o1, but there is not any method which will solve it in o1. I read many blocks and other stuff, but I will not find any method. Okay, I did not find any. That's why I initialize everything with 0. So this is n plus 1 is equal to 0. You can see You can see this n plus, I am taken size 5 and initialize it with 0. So whether I come here like after 90 I don't have any index, so I will come here, I will just add 0 to it. Okay, elsewhere I need to check if I am taken is uh, of size n, then I will check if my size is greater than is equal to n, I will add 0, or either I can take this n plus 1 size. Okay, now for each index n minus 1 from last up I greater than 0, I minus minus. If I am not taken it, if I am not taken it, then it is dpi plus 1. If I am not taken it, dpi plus 1. Not taken it, not taken it, not taken it, not taken it. Now, okay, now if I taken it, initially mark it as 0. Okay, or you can mark it as, okay, mark it as 0. Now I will find the next index. I am finding the next index that from starting from I can take my channel length further, like I is I plus 1. Like for this, if I am searching, for this index I am searching, my last element can be possible this. My I am initialized my next, means my next index to n, means if there is not any index that is satisfy my condition, then I will automatically add 0. But my r is this, means, and l is this, so between l and r I am searching. This is just a simple binary search. While previous, what is previous element? Previous element is 28, means I need to found element greater than 28. So I plus 1, r is n minus 1, next is equal to n, next is the index, I am putting it n. So if I don't found any n, then I just add a dp of next. If next is equal to n, then dp of n will always be 0, because I am not doing any operation on dp of n, I am starting from n minus 1. So while my L greater than is equal to R, I am taking the mid element, and if mid element dot first value greater than previous, means it is fulfilling my condition, then what I am doing, next is equal to m, means this can be a valid next index, and I am searching for smaller, more smaller, because the more bigger range of element I have, or the more bigger L comma R I have, the more bigger chain length possibly I can found. Okay, then what I will do, if my pm dot first is greater than previous, means I need to increase my size or increase my value, so I will just increase my index l to m plus 1. This is why I am doing searching, because after searching this will reduce to n log n from n cube, because without searching you go up, you go for, or n square, without sorting it will be n square definitely, but after searching using n log n in searching, n log n in this, so total time complexity you can say is n log n plus n log n, that is 2 n log n, that will is equal to n log n. Now my take is 1 plus dp next. So what I am saying you, it is 1 plus dp value of the next index from which you can start your chain further. Dp value of, for this 28, the next value is this. So the dp value of uh, this dp value of the next index from which you can start to make chaining. After 24 I have this 2. So dp value of the next index from which you can start your chain. So, and dpi means the from the current index, it is the maximum of take comma not take, else while I and after completion of this I just written dp comma 0, means dp0 will always contain the maximum answer for me. You can see all the test cases pass out. Okay, so these uncorrect submission are because I am writing memoization code. This is just a memoization code, if in case you want to. So I just don't delete it. This is the function I write. If current greater than n and return 0, if dp values initialize means already calculated, return it, else while not take, check for further, take. Similarly doing binary search, then it is 1 plus solve to the next index, because you are doing memoization. Then dp return dp का result to maximum. This is memoization code which would give me segmentation false. So I hope you all understand the problem. If you have any doubt, then just comment out, I will try my best to explain you. This is a very important dp problem with binary search. Okay guys, so if you like the video, please comment out and like subscribe the channel, and you can check out my channel for more these type of videos. Thank you for watching this guys, stay tuned.